So for part A, number 1, they want to put the mass of 50 kilograms. And then for applied force is 50 newtons, and the friction is a half. So the box is not moving, and that shown that friction force is 50 newton and applied force is 50 newton. So sum of force is 0 because the box is stay.
Assalamualaikum, my name is Siti Maisara. So today I want to show how to do for part A. First thing is select the friction box and then choose the box with mass 50 kg. Set the friction to any non-zero value. So I want to show how to do for step 8. First, increase the applied force to 150 Newton. After that, when box in motion, kinetic friction, observe the sum of force, max friction force and the applied force. So just that for today. Thank you.
Part B is about friction properties. Open the link given and you will see this page. After select the friction, set the value of friction to halfway and press the second box on the first. The total of the box is 100 kilo. Increase the applied force. We can see the box is moving, and we can get the maximum value of friction force, applied force and sum of force. Increase the applied force. We can see the box is moving, and we can get the maximum value of friction force, applied force and sum of force. Increase the applied force to 500 Newton. Remove the applied force to 0 and reduce the maximum value of friction to 9. You can see the person will stop pushing the box and the speed is constant. The box is still moving because the object is like with small surface and has low friction, coefficient friction. And then increase the friction to lots. The speed is decreased and the box will stop because the box like with the rough surface and has high coefficient friction.
Hi and Assalamualaikum. So today I'm going to show you guys how to find the coefficients of static frictions. Okay, the first thing you have to open the simulations. Okay, next you can set your own angle value, coefficients of frictions between M2 and surface value, and then your mass, which is M2 and M1. Okay, for example, I set my angle 0, my coefficients of frictions is 0.25, and my mass for M2 is 6 kg. Okay, the objective if I'm want to show you guys what kind of mass M1 that can make M2 is barely moving towards M1. Okay, for example, like something like this, still moving, right? So you can reduce the mass for M1 and still reduce, 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 and reduce. Okay, it shows that when I put it 1.5 kg, the M2 are not moving, right? So I just increase a bit the mass for the M1. Okay, I put it 1.6. Okay, and I run. Okay, as you can see that M2 is moving towards M1. So which means the value. So the observation here is that the mass for M1 equal to 1.6 kg can make mass M2, which is 6 kg, moving towards to M1. So, okay, that is my observation. So thank you for listening and Assalamualaikum.
So for part B2, we want to set A to 30 degrees. Okay. Then for example, we set the mass of M2 to 10 kilograms and coefficient of friction between M2 and surface is 0.25. What we want to search is the mass of M1, so we need to search which kilograms, the box of M2 is slowly move forward to M1. So okay, just search one by one. Then as you can see, mass of M1 equals to 7.2 kilograms is the slowest.
Assalamualaikum, my name is Siti Maisara. So I want to show how to do for part B, coefficient of static friction. Okay, I want to show how to do for step 8. First of all, set the angle to 0 degree and then set the mass of M2. For example, I use 6 kg and then set the coefficient of friction to 1.0. After that, take the show numerical value. So we can see the force of kinetic friction, acceleration, tension and spring, time and velocity. Next step is click the run and then slowly reduce the mass of M1 until M2 barely move towards M1. So we can see the mass of M1 at 6.1 kg. The M2 is barely moved towards M1. Record the weight of M1 and M2 in the table 3.
I will present part B about coefficient of static friction. First, set angle to 30 degree. Mass of M2 is 6 kg. Set the coefficient of friction to 1 according to the lab sheet. Slowly reduce the mass of M1 until the M2 is barely moving towards M1. Like this. and click run. Okay, we can see the M2 is not moving, so we need to change mass of M1. Increase the mass of M1. Click run. Okay, now we can see the M2 is slowly moving forward because the M2 slide with the rough surface and has high coefficient of friction. We can get the value of force of kinetic friction, acceleration, tension in string, and velocity right here.